Hello and welcome. So I'm going to quickly go over what grab passes are and what they can do with shaders. So here's a shader using a grab pass. It's basically inverting the scene behind it and it's a bit of distortion as well. The nice thing about this effect is you can actually chain it. So you see the inversion of the inversion is the original. Really nice effect, and it's quite simple to put in terms of like lines of code anyway. So here's the shader, and it's got this thing called a grab pass. This is a multi-pass shader, and the first pass is a special pass called a grab pass, and that's it. There's nothing to it at all. This is basically says write the screen to a texture that later passes can use. Now you can specify a name for your texture. I've left it blank here. What happens then is it uses a default name, which is _grab texture. So create a sampler with that name in order to sample the texture. Ultimately, when you get to your fragment shader, you're going to want to sample that texture in order to do stuff like here I've inverted the color, for example. The problem is that the texture is in screen space because of course it's the screen that's been saved to a texture, so you need to have your UV coordinates. You need some screen UV coordinates. I'd recommend a way of doing this, or at least the ways that are in the Unity examples, is there's two methods to use. The first one is compute grab screen space pos, and that's used in your vertex shader, and it'll basically convert your vertex 3D position into a screen space coordinate that can effectively be used as a UV coordinate for the grab texture. So then once that gets through to your fragment shader, you then have to use, you're not going to be using text 2D to sample the grab texture, you're going to be using text 2D proj. And the reason for that is, let's just see what happens if you use text 2D. See, everything's messed up. Now put it back to text 2D proj, so everything's correct again. Now you can use text 2D if you do this, which is divide the UV grab by the W component. Yes, it's got a W component. This method returns a float 4, not a float 2. There's information in the W component. I think there might even be information in the Z component. But in short, you can get the correct effect by dividing by W, but I wouldn't do this. I think it's better to use the I guess this is the kind of like the best way of doing it. Use this text 2D proj. It might do additional stuff other than just dividing by W. I also read somebody saying that the reason for using this, it might just be down to performance, because doing this for every pixel is bad performance really, and this is somehow avoiding doing that. I'm not sure how, but yeah, generally I guess the best thing is to just do that. Now you can't actually divide by W in the vertex shader. I did give this a go, like sort of hopeful, so I don't like having to remember to use different methods. If you do this, then you get things, I don't know if you can see, that things are a bit distorted. Oh, there you can see. And I think this is because of the interpolation. So you have to do the division by W at the very end before the interpolation that happens from the vertex to the fragment shader. But anyway, avoid all of that hassle just by remembering to do that, and it's in the kind of the examples anyway. So the other thing I was going to talk about was what happens if you use a named texture instead of this default. Well, first thing to note is that at the moment every use of the shader, so these two objects are using the shader, they both run this grab pass and create this texture, which allows this chaining effect. Now if you use a named texture, well, first of all you've got to make sure your sample name is the same, and also down here. If you do that, you seem to lose the chaining effect, and the reason for that is that using a named texture, it will only be generated once per frame before any of your objects have been rendered. So all of your objects are basically going to see something like this as the screen, and as a result you're not going to get the chaining effect. Now that can actually be a benefit if you for performance, because you might have thousands of objects and you don't want them all to be grabbing the screen each frame. And that's it. Thank you for watching. Check back next time for something else presumably, and goodbye for now.